This is part 3 of section 2.4 for Intro to Proofs. We're going to do progress check 2.21, negating quantified statements. So we're going to look at a bunch of statements. We're going to write them in English. We're going to write them negated in symbolic form, and then write the negation in English. So first we're going to start off with, so this is 2.21.1. Negating quantified statements. So here our statement is for all a in real numbers, a plus 0 equals a. So in English, for any real number a plus 0 equals a. And notice I still use an equation because writing equations in English is ridiculous. So what I'm trying to get you to think about is quantifiers and how we use quantifiers with English, not writing a ridiculous equation. It's like a plus 0 equals a. You just use equations. Okay, now let's negate it. To negate a quantifier, we move a negation past a quantifier, for alls become there exists. So there exists an a in real numbers, such that a plus 0, and then you have to negate this inner part, is not equal to a. So there exists a real number a, such that a plus 0 is not equal to a. All right, let's look at our next statement. Our next statement is that for all x in the real numbers, sine of 2 times x equals 2 times sine of x times cosine of x. So what I just said, for any real number x, sine of 2x equals 2 times sine of x times cosine of x. Now let's negate it. And negating it for all means that there exists. So there exists an x in real numbers such that sine of 2x is not equal to 2 times sine x times cosine x. Writing that in English, there exists a real number x such that sine of 2x is not equal to 2 times sine of x times cosine of x. The next statement is for all x in the real numbers, tangent squared x plus 1 equals secant squared x. In English, for any real number x, tan squared x plus 1 equals secant squared x. Negate it. Moving a negative past it for all makes it that there exists x in the real numbers such that tan squared x plus 1 is not equal to secant squared. So I change quantifiers. I basically swap quantifiers and then have to have a negation on the inside. So there exists a real number x such that tangent squared x plus 1 equals secant squared x. So for 2.21.4, we have this statement. There exists an x in the rational numbers such that x squared minus 3x minus 7 equals 0. So another way to say it is there exists a rational number x such that, I think that's what I just said. So it's, all right, this says what I just said. And then negating that, moving a negation past that there exists, turns it into for all. So for all x in the rational numbers, x squared minus 3x minus 7 is not equal to 0. So you change quantifiers and you change equalities to the opposite. If it were less than, you change it to greater than equal to. Never is the opposite. Then for any rational number x, x squared minus 3x minus 7 is not equal to 0. Okay, finally, we have part 5, negating this one. So there exists an x in the real numbers such that x squared plus 1 equals 0. So in English, there exists a real number x such that x squared plus 1 equals 0. Negate it, so there exists turns into for all, and then x squared plus 1 turns into not equal to 0. So for any real number x, x squared plus 1 is not equal to 0. That concludes part 3, which is progress check 2.21.